specification. Bike manufacturers commonly use high-tensile, or high-strength, steel fasteners as they're cheap, can be used pretty much anywhere on the bike, and also saves on assembly time at the factory. They normally have a low alloy content, with small quantities of other materials, e.g. 1.5 to 2% manganese, present that provides additional strength in the cheapest way possible. Sometimes poorer quality material substrate can be used, which can be painted or thinly plated instead. Why stainless steel is used a lot? This is a steel alloy with a minimum of 11% chromium content. It does not stain, corrode, or rust as easily as ordinary steel. It stains less, but it is not completely stain-proof. There are over 150 stainless steel grades with varying surface finishes are available, brushed, satin, etc., and it can be milled into pretty much anything, like bars, wire, tubes, coils and plates. To resist oxidation in ambient water temperatures further, more chromium can be added. Up to 26% can be added for use in severe environments. Chromium is used because it forms a layer of chromium oxide when exposed to oxygen. This layer is very thin, you cannot see it, and protects the steel underneath from water and the resulting bad effects. If scratched, this layer has the capacity to quickly intervening reform, or heal, itself. Called passivation, this process is also seen in aluminum and titanium. Stainless steels can also be defined by reviews their crystalline structure. Austenitic, non-magnetic, 300 series stainless steels are the most widely used. This type is a chromium-nickel alloy composite, containing minimum 16% chromium and a maximum of 0.15% the carbon, plus enough nickel, manganese to keep its austenitic structure at all temperatures. The two most common grades are used for motorcycle fasteners: 304A2 and 316A4. A2 is the most prolific, and is known as 18/8, 18% chromium, 8% nickel content. A4 is made up of the 3rd of October 18% chromium, 10% nickel and 3% molybdenum, and can be known as marine grade due to its added corrosion-resistant qualities, especially against salt water or acids. Detail parts. Product: Kawasaki 125cc Athlete AX125B 2011 edition. Blue color parts. Bolt for rear wheel. Corrosion is a natural process, which converts a refined metal to a more chemically stable form, such as its oxide, hydroxide, or sulfide. It is the gradual destruction of materials, usually metals, by chemical and/or electrochemical reaction with reviews their environment. Type of the corrosion: galvanic corrosion, also called bimetallic corrosion, is an electrochemical process in which one metal corrodes preferentially to another when both metals are in electrical contact. In the presence of an electrolyte, this same galvanic reaction is exploited in the primary cells to generate a useful electrical voltage to power portable devices. Galvanic corrosion occurs when two different metals have physical or electrical contact with each other and are immersed in a common electrolyte, or when the same metal is exposed to the electrolyte with different concentrations. In a galvanic couple, the more active metal, the anode, corrodes at an accelerated rate, and the more noble metal, the cathode, corrodes at a slower rate. When immersed separately, each metal corrodes at its own rate. What type of metal to use is readily determined by following the galvanic series. For example, zinc is often used as a sacrificial anode for steel structures. Galvanic corrosion is of major interest to the marine industry and anywhere also water, containing salts, contacts, pipes, or metal structures. Factors such as the relative size of the anode, types of metal, and the operating conditions, temperature, humidity, salinity, etc., affect galvanic corrosion. The surface area ratio of the anode and the cathode directly affects the corrosion rates of the materials. Often galvanic corrosion is prevented by the use of sacrificial anodes. Causes of galvanic corrosion: dissimilar metals and alloys have different electrode potentials, and when two or more come into contact in an electrolyte, One metal acts as the anode and the other as the cathode. The electropotential difference between the dissimilar metals is the driving force for an accelerated attack on the anode member of the galvanic couple. The metal anode dissolves into the electrolyte, and the deposit collects on the cathodic metal. The electrolyte provides a means for ion migration whereby metallic ions move from the anode to the cathode within the electrolyte. This leads to the metal at the anode corroding more quickly, intervening than it otherwise would, and corrosion at the cathode being inhibited. The presence of an electrolyte and an electrical conducting path between the metals is essential for galvanic corrosion to occur. Galvanic corrosion can be prevented by 1. Selecting materials with similar corrosion potentials. 2. Breaking the electrical connection by insulating the two metals from each other. 3. Applying coatings to both materials. The coating on the cathode is the most important and must be in good condition, otherwise the galvanic corrosion could be worse. 4. Separating the two materials by inserting a spacer suitably sized. 5. Installing a sacrificial anode that is anodic to both metals. 6. Adding corrosion inhibitors to the environment. If refused, these measures are not practical. The rate of attack can be minimized by keeping the anode to the cathode large area, i.e. over 10. Alternatively, the anode could be designed with an appropriate corrosion allowance. Galvanic action can cause preferential corrosion of welds in certain environments. For example, in rainwater. Carbon steel weld metal can be susceptible to severe corrosion, whilst the adjacent parent material is unattacked.
Thank you for watching and support this video. Don't forget to
like, comment, subscribe and dislike.
Okay, bye-bye!